Okay, let's now move to bending plus torsional loading case. And here, the first thing I'm showing over here is a pure bending case plus a pair of torque applied on the same shaft. All right, the diameter of the shaft is d or phi again. And now, in this case, you can see that actually each cross section we should say the same thing. All right, and every point at the bottom of this shaft should have the same stress state. Every point at the same location should show the same stress cases. Okay, so I pick up one point, which is the red dot. Okay, like this. So the red dot is under tensile normal stress, which is the bending stress is positive tension. Okay, but shear stress is all around, as I show you over here. All right, so the shear stress, which is the maximum on the surface, as the expression we have just reviewed. The normal stress, which is also on the surface, okay, in the expression we just reviewed. All right, so at this red dot, again, both the normal stress due to bending and the shear stress due to the torque are maximum. Now, this is we move to the transverse bending plus the torsion case. Now, same shaft, but the load applications are changed. The torques are still the same, but the bending case we changed into this transverse loading case that I have force and then reaction. All right. Again, for this case, I have one force at the middle and two reactions at these two sides. All right. So you see here, the middle force is 2F, and the reaction force is F at each side, because in this case, I particularly make this symmetric. Okay, the stress state. Now, at each cross section, we are not going to see the same thing, all right, because now we have a transverse loading case. The moment at each cross section is different. But this red dot should show us the same stress state as the one we see from the top case, all right, which is like this. All right, the normal stress bending due to bending is positive, so tensile bending stress, all right, shear stress basically show the same thing. But the values are a little bit different. The torsional shear stress still give the same thing. So this is the same as the one we see from the top. But the bending stress, and here expressions are still the same. But here, because the bending moments are different from the one we show from the top. Okay, here we just show the moment, and here the moment is produced by force and L. So moment becomes FL. All the other things are the same. Okay, so what is the difference? What is the difference between these two cases? Okay, and that is the transverse shear stress. Okay, so how about the shear stress at the neutral axis? That's the question we're going to ask. All right, so if I pull out the same thing that we show before, okay, for when we talk about the transverse shear stress. And here I show you the neutral axis, and for this case, and we know in neutral axis we have the transverse shear stress, which is not here in this case. All right. Right, we see maximum is along the neutral axis, but don't forget, along this neutral axis, we also have the torsional shear stress, okay, which goes like in this way. All right, so the torsional shear stress at each location can be added, and we're only interested in the stress right at the surface, in the surface. Okay, this side, the one's positive, one's negative, so they're opposite. So basically, the one substrate, the other one. But on this side, two things add together. Okay, if we pull out pull out one element at the back. You see here, I did the cross section. Okay, I did the cross section. I did the cross section right across this red dot. Okay, and then this is the cross section. So if I view from back, I should have such a stress element. And basically, the shear stress is the summation of the transverse shear stress and the torsional shear stress. We add those two things together. Okay, so this basically, that's the difference between those two cases. Now, I have one more thing to ask. How about the stress state at point 1, 2, 3, and 4? Okay, and we are very clear at which point is 3. So 3 basically is exactly this case, the red dot we show over here, right? So this is 3. We should have shear stress. We should also have the normal stress. Okay, how about 1? 1 and 3 are basically 1 and 3. Okay, 1 and 3 are basically the same thing. The only difference is that the normal stress becomes compressive. Okay, how about 2 and 4? Okay, we talked about 2 and 4 already. So basically 4 has smaller shear stress and 2 has larger shear stress because at 2 we have 2 different shear stresses add together. Okay, that's the end of this